morning students, it is video number 24 of class 8 chemistry. It is part 3 of lesson 6 chemical reactions. Decomposition reaction. In a decomposition reaction, one substance breaks down into two or more substances. For example, decomposition of water. On electrolysis. Electrolysis means breakdown of a substance by passing electric current from it. So electrolysis is a process in which a substance is decomposed or broken down into simpler substances by passing electric current through it. We have to mix little acid or some drops of acid inside the water. When we add acid, it becomes acidulated and it will allow electric current to pass through it and help to break hydrogen and oxygen on electrolysis. During electrolysis, when we pass electric current from water, it forms hydrogen and oxygen. How we can perform this experiment, the electrolysis of water? We have to take some water in a beaker and we have to put some acid, maybe hydrochloric acid or sulfuric acid in a beaker. 2 test tubes full of water we will invert inside the beaker. We will remove insulation from the ends of the 2 thick wires and introduce them inside the test tube. Connect the wires with the battery, one with the negative terminal, one with the positive terminal. Then we will start passing current for some time. Gases start collecting in the test tube. We will observe water level from the test tube. It decreases and upper empty space or gas collection it increases. On positive terminal, oxygen will collect. On negative terminal, hydrogen gas will collect in the test tube. Now, when we stop passing electric current from it, we will take these test tubes out from the beaker and cork their mouth so that these gases will not come out from the test tube. Now we want to test that which gas is collected at which terminal. So we will do some experiment. We will take a lighted match stick near the mouth of the test tube and open its mouth. The gas burns with pop and so it is hydrogen. Similarly, the gas collected over the positive terminal, we will take the glowing matchstick near the mouth of the test tube, remove the cork. The matchstick gets lighted. So we come to know that in this test tube, gas collected is oxygen. We come to know the volume ratio of hydrogen and oxygen in water through this experiment, that is 2:1. Another example, decomposition of baking soda. The formula of baking soda is NaHCO3. What is the another name? Sodium hydrogen carbonate. So how many elements are present in the formula of baking soda it represents? Sodium, hydrogen, carbon, oxygen. On strong heating to sodium bicarbonate, it decomposes and breaks down into sodium carbonate in solid form, water in gaseous form, and carbon dioxide gas will form. Another example, potassium chlorate decomposition reaction. How potassium chlorate decomposes into 2 or more substances. Potassium chlorate, we will heat it in the presence of catalyst manganese dioxide. Then we get potassium chloride and oxygen gas will liberate. Mean this substance potassium chlorate, it decomposes or break down into 2 or more substances. That's why this reaction considered under the decomposition reaction. And about manganese dioxide, we know it is a black colored substance. Before putting potassium chlorate we have to heat manganese dioxide so that the carbon from this catalyst totally evaporate after heating. Because when we add potassium chlorate inside the beaker or the test tube in the presence of this catalyst, it can cause explosion. To avoid this, we have to heat manganese dioxide, that catalyst, before this. Afterward, we will put potassium chlorate. Again, we will heat it. Then it decomposes in form of potassium chloride, and oxygen gas will form. Displacement reaction. What is displacement reaction? When one element displaces another from compound and take its place. We come to know about the displacement reaction when we studying about the activity series. In activity series, we know that the uppermost metals are more active than the lower one. We know higher an element is placed in the series, that elements are more active. Whereas elements below the hydrogen in the series are less active. Potassium, sodium, calcium, these are the active metals. Whereas iron is less active than the sodium and potassium. Now we observe during displacement reaction that more active metal displaces less active one from its compound. Let's discuss some example of displacement reaction. We know in the activity series, potassium, sodium, calcium, these are the highly active metal in activity series and at the top. When these metals react with water at normal condition, then it will form hydroxide and hydrogen gas will be liberated. It means potassium, sodium and calcium, these are the highly active metal. It displaces hydrogen from it. Similarly, magnesium, it is a less active than the potassium, sodium and calcium. So at normal cold condition, magnesium will never react with the water. It will react with the water at higher temperature. So it reacts with the steam. Magnesium ribbon or magnesium metal, it reacts with the water in steam form. It forms magnesium oxide and hydrogen gas will liberate. In this reaction, we come to know that magnesium atom, it displaces hydrogen atom from the water. And a less active metal like magnesium, iron and zinc, they displaces hydrogen from dilute hydrochloric acid and sulfuric acid. Now see, when zinc reacts with the acid, dilute hydrochloric acid, then it displaces hydrogen from it. It will displaces in form of hydrogen gas, and another atom it combined with zinc to form zinc chloride. Similarly with the iron, when dilute sulfuric acid added into it, it displaces hydrogen from acid in gaseous form, and sulfate group combined with iron to form iron sulfate or iron 2 sulfate. In this way, these less active metals, they displaces hydrogen from the acid. Displacement of copper from copper sulfate by iron or zinc. When iron nail is placed in a copper sulfate solution, that is blue in color, there is a brownish or brown red deposit of copper over the iron object. After some time, we will observe that the blue color of copper sulfate changes into the green and form iron 2 sulfate. When iron reacts with copper sulfate, it displaces copper from the copper sulfate and form iron 2 sulfate, which is green in color. We know copper sulfate, it is blue in color. Similarly, zinc, when placed in copper sulfate solution, which is blue in color, it also displaces copper from copper sulfate and form zinc sulfate and copper, which is brown red in color, and zinc sulfate solution formed in the test tube, that is totally colorless. Note down some question for the revision practice. Question 1. What is chemical formula of baking soda? Question 2. What are displacement reactions? Question 3. Complete it. When zinc react with dilute hydrochloric acid. And second, what happened when sodium hydrogen carbonated heated up?